Okay.
Okay. Hello, this is Neda. Um, in our group member, we have Karthik, Pavan, and me, and we're gonna talk about SPIKE, intelligent scheduling of Hubble Space Telescope observations. The SPIKE system created the Space Telescope Science Institute for NASA's Hubble Space Telescope is described in this paper. The scientific community places a premium on marketing efficiency as demand for research grade telescope outnumbers supply because of their extremely high cost, limited numbers, and unique scientific potential. Space-based facilities have a particular needs for efficient scheduling. The HST scheduling challenge is one of the largest and most difficult scheduling problem in contract on a regular basis. 10,000 to 30,000 observations are scheduled each year, and each subject to a variety of operational and scientific limitation. Exposed restriction include relative temporal criteria such as precision and minimum and maximum time separations ordering, and which can be specified by professors in order to communicate scientific goals, and some observation must be completed in a specific amount of time. And a number of schedule limitations are imposed by the HST spacecraft and its accompanying ground system components. And the amount of variable observation time is the main resource limitation for HST. Constraint provide the schedule with two sort of information: feasibility constraint and preference constraint. Feasibility constraint states when the activities may or may not be scheduled under certain conditions or at certain times. And preference constraint specifies quality judgments on scheduling conditions which are preferred but not required. Combination of preference and suitability function. In general, there are two number of constraints acting on a job. Therefore, the degrees of preference W from all applicable constraints must be combined. And this technique is formally similar to that used in a variety of rule-based expert system that valued evidence for and against various conclusions. And constraint that describes time when an activity cannot be scheduled are common in scheduling challenge. And there are some crucial basic because they allow to the scheduler to exclude time blocks from further consideration. And consistency methods for consistency methods approach have long been recognized to improve search efficiency, and they have also proven to effective in SPIKE. The information that is implicit in the restrictions is made explicit but by consistency approach. And there are some techniques for speeding up the scheduling process, which they are non-consistency, arc consistency, and path consistency. Node consistency refers to the exclusion of domain value that cannot be part of any solution based on unary restriction. Arc consistency is to meet binary restriction. It is necessary to remove values from variable domains, and path consistency refers to the interface of additional binary restriction from those that have been expressed explicitly.
Yep. Let me go through the slides from my side. So good evening, everyone. So today I'm going to discuss about the computational aspects. So in this, we are going to avoid the fundamental discriminations of the time in the Spark for two reasons. So one reason being the artificial space graduality in the issue, into the issue, and the second will be the significant restrictions results in the suitability functions with extends the period of constant value, which might be represented insufficiently by a large number of identical values at many discrete time points. In order to execute the um, suitability efforts on digital hardware, we must be discriminate in the time value or both. Suitability is not just a collection of data. It and the basic constraint representing the approach place restrictions on the timing or suitability value that may be stated. So the next slide deals with the HST scheduling as a constraint satisfaction problem. So it this ACSP is made up of a number of variables, each having a discrete value domain and a set of constraints that limits the permissible values for each variable based on the values applied. Uh, as well as we allocate a variable to each activity to schedule and to divide the scheduling time range for each activity into the intervals based on the domain of the associate variable. So the next slide will be the Spike CSP toolkit. So this toolkit is useful for the is contains the number of useful features, including the inconsistent assignment, logged and ignored variables, removal and restoration of domain value, constraint weights, constraint catching, assignment history and snapshots, and capacity constraints. So when coming for the inconsistent assignment, these are the variables may be assigned values that are conflicting with the other assigned values at any time. And logged and ignored variables can be enforced to have a sufficient value before being ignored. Removal and restoring of domain value is a variable domain value can be omitted from the issue at any moment and subsequently restored. Constraint values can be given at any weight value, which determines how much the conflict count is increased for each violation. Constraint catching is a toolkit which includes a feature that allows you to save the efforts of the current set of provided values. Whereas the assignment history and snapshot includes an assignment history feature that allows you to mark the current state and go back to any previous marking. Whereas the capacity constraint is the mapping of the domain value to capacity bins and has to be a many to one or one to many in this. And the next slide deals with the time slamping. And this time slamping is for the large chain in scheduling the constraint, as well as the sampling intervals must be shorter than the time frame. For this time slamping, if the requirements are met, the next step is to choose a sampling technique that specifies how to handle strict constraints that prevents the scheduling of an activity across the part or but not all of the specified period. And next slide deals with the scheduling search in the spike as well as the trial assignment heuristic. So spike approach scheduler constructions has a constraint optimization issue and employs multi-start sophistic repair, a heuristic repair based schedule search strategies. This scheduling search contains trail assignment, repair, as well as the deconflicts. The way when coming for the trail assignment is a key for the repair-based technique. Therefore, we have done a lot of testing on different combinations of variables and values selection to figure out which one are the most efficient. Whereas the repair heuristics are based on the successful neural network that designs the development specifically for the spike and improves into a sample symbolic form that has no replace to the neural network. Deconflicts may employs a strategic forward method for removing the conflicting events from an overbooked schedule. And next slide deals with the repair heuristic and deconflict. So for a repair conflict is a time selection in which tasks are relocated to times when the number of conflicts is lowest. And main conflicts has been founded to be quite successful in fixing the appropriate trial assignment in both the theoretical as well as the numerical studies. And these repair heuristic and deconflicts are the low priority and large number of constrained conflicts, and the lower preferred time assignments are used to determine which activities should be deleted. And the next slide deals with the scheduled quality measures. The number of observations on the schedule as well as the total observation time schedule and the some degree of the preferences are important indicators of the schedule quality. And the time frame of the activities to be planned or within a time, the total gap time in the schedule serves as one component of the quality measures, indicating how much time potentially be used if the appropriate activity are available. Spikes helps in the rescheduling in a variety of ways, in which task locking and conflict cause analysis are the two important features of the CSP toolkit. And the next slide deals with the rescheduling. So for this rescheduling, the spike can assist you with the rescheduling in number of ways. Like job task can be the planned ahead of time and will not be securitized during the search or a repair procedure. Using conflict cause analysis, the users may mm, place a task onto the schedule and discover which restrictions are exceeded by which both of these tasks. And the next slides will be discussed by my teammate Karthik. Over to Karthik.
Hi. Moving to the my slides, I discuss about planning and pre-scheduling and scheduling. Like spike dehydrating science scheduling. In 1990, the HST was initially introduced. The high-level scheduling flow of the HST ground system is depicted in the diagram, which is addressed in the section and further extensive in Miller and Adorf and Miller and Johnston. Moving to the next slide, preparing an observing proposal. An astronomer wishing to use the HST must first submit an observing proposal satisfying the observations to be made. This purpose is the primary source of data used in the planning and scheduling process. Moving to the next slide, preparing an observing proposal. Long-term scheduling. Because the HST scheduling challenges involve such a wide range of dates and tons of thousands of accuracy, a two-tiered scheduling solution was used. A one-year plan that assigns responsibilities to certain weeks or sections of weeks is known as a long-term plan. Week-long pieces for the long-term plan are used for short-term scheduling. The spike system, which was developed at the STSCL, is used for long-term planning. Short-term scheduling. Short-term scheduling employ the science planning and scheduling system SPSS to complete the final sequence of groups of observation in less than a week. Compile a full command list and send the findings to HST payload operations control center as the science mission specification. The STSCL is in the charge of maintaining SPSS, which was established by TRV. Proposal preparation. Proposers are the HST are selected based on a consequence explanation of the programs satisfying purpose and the observatory resources required to achieve it. Each proposer presents their observations once a peer review system has authorized them. Must write a clear explanation of the exposes to be carried out our real-time control of the telescope. Nearly all observations are planned and conducted due of the complexity of the HST and its ground system and the astronomers' lack of experience with them. The Space Telescope Science Institute in Baltimore was chosen. Transformer mention. The following stage is essential one of the preparation given the high atomical orientation description of the observations in the phase 2 plan. The transformation system job is to translate the astronomers' declarative proposal into a scheduling unit, which is a collection of aggregate exposures and reactions. Moving to the next slide. Implementation. In this article, we examine some of the implementation problems for Spike, a real-world application of artificial intelligence technology early in 1987. Texas Instruments Explore Lips computer were used to develop Spike. The Spike was built with Intel Crop common window, but the rest of the system was developed with the common lip and the flavor object system. For Spike operation, development and testing, STSCL had a complement of 8 micro explorers and explorers at the time of HST launch. Application of Spike to other astronomical scheduling. Spike has been modified to deal with a number of astronomical scheduling issues. 2 of them are already on their way to begin operation, while the others are still in the proper rate of planning stages. The experience of changing Spike for observing circumstances was actively sought throughout the development of the Spike. Each example give output on the process, resulting in the improvement for one version to next. Conclusion. The Spike scheduling system had aided NASA's Hubble Space Telescope. The appropriate function since Spike provide for a more world scheduling decisions. It was been proving by adapting into a variety of spacecraft mission using the same constraint representative and sets approach, combine long and short time scheduling at the distinctive level of abstraction. Thank you all for giving this opportunity. Hope you do this too.
Thank you.